Thank you guys. So I'm Shakthishree Manjunath. I work as a software developer here at KIS, and today I'll be talking about reusing the code base. Right. So we already had a talk about modularity, modular implementation of methods in our application, right? So yeah, that's what is reusing the code base. Say you have a requirement of writing a format method for a currency value, right? You are displaying cost value in 6 different screens of your application, and you are supposed to add the dollar sign in 6 different screens. So what you do, you are going to write your format function in 6 different screens of your application, maybe with the different names if you have multiple members in your team, right? So then in the middle of the development process, if there is any modifications required, say there might be a requirement from client side which says it should not be dollar symbol always, it should change based on the country in which the application is being used. Then you'll have to search for that particular functionality throughout your application, and you'll have to make the same change for 6 different times, right? So that's hectic. And also if there is a bug in your format method, then you'll have to again search for 6 different screens and make those modifications for 6 different times. So rather you just take out the format method, keep it at one particular place and reuse it everywhere. So if you have to make any modifications in the middle of the process later, you can make it at one place and it will get reflected everywhere. And same goes with the bug fixes. So I guess we already saw the advantages of code-based reuse, right? So let's see, when I say code-based reuse, I can reuse the code base within the application, right? We just saw an example as to how we could do it. And we can reuse the code base between the application which uses same syntax. That is, we can reuse the code base between 2 React Native applications. Say we have native base UI component module and we are using it in multiple React Native applications, right? Or I can reuse the code base between the applications that are written for multiple platforms. So in today's talk, we're going to focus on the third point, that is reusing the code base between the applications that are written for multiple platforms, for different platforms. Right, we are going to see different approaches in achieving this, advantages and disadvantages of each approach, right? So say you have a requirement, you have this product and you want to develop this product in mobile, web and desktop. So you can see that in mobile you need it in both iOS and Android, and in desktop you need it in Windows, Mac and Linux, right? So we already have React Native. You can write just once and run it in both iOS and Android. So let's use React Native for building our mobile application. Then we have React.js for web application, and we use Electron for desktop application. For those who don't know what Electron is pretty famous. It's a JavaScript framework which is used to create a desktop application, and it runs in all in Windows, Mac and Linux, right? So if you can see here, when I say a single product needs to be implemented in 3 different platforms, it would use same set of APIs, right? Same set of APIs, and the business logic would also be the same. So literally you're like writing the same code in thrice in 3 different applications again and again. You're duplicating the code thrice. So how can we avoid this? It's better to write once and run it everywhere, right? You always have to share the code rather than wasting your time and duplicating your code. So the same, you have the same product, you need it in mobile, web and desktop, but this time we're going to write a single code base and we're going to run it in all the 3 platforms. So this seems like a very interesting concept theoretically, but is it practically applicable for a production level application? Well, that's what we're going to see. Okay, let's go through different approaches step by step and see which approach would help us achieve this. Okay, so this is another requirement. Say you have to implement, you have to develop a simple application with a login screen and a home screen. So this is your login screen in your mobile, this is your login screen in desktop, and this is your login screen in web application, right? So if you can see here, the design of the login screen is the same. And since this is a very simple application which has only login screen and a home screen, we can always reuse the code base. It's not very difficult to reuse the code base. So let's first connect our and assume that we already have a mobile application implemented for it. You already have a mobile application and you need to get your web and desktop application for the same product, right? So let's first look as to how we connect our Electron, that is desktop application, to the web application. So this, while configuring the Electron provides you a facility of specifying the initial HTML file that you want to load on your main window, right? So initially when you are creating your main window, you can specify the URL of the HTML file that you want to load in it, right? So what we can do is, whenever you are creating a build in your web application, you get that .html file in your web application, right? So we can use that, we can point our URL to that particular file. So now we have already connected our web application to the Electron application. So now we have to think as to how we are going to get the code from mobile to web, right? So obviously we have various React Native third-party libraries that are available that would help you in reusing the React Native code base in your web. React Native Web, React Native Windows, React Native Mac OS, you have many other like React Native Desktop, lots of third-party libraries that would let you use your React Native syntax in your web application. Now React Native primitives is a bit different than the other ones that are specified here in the list, because it provides you the components that are platform independent. That is, in React Native Web, what you do is import Vue from React Native. That's what you do whenever you're using React Native Web, right? But in React Native primitives, you will have to import components from React Native primitives itself, from that component itself. So you can think about it whenever you are whenever you have code-based reuse requirement from the scratch before even starting the development, right? Okay, but now we copy pasted the code, we used React Native for web, now we have it in the web application. Now we have already connected your web application to the Electron application. So good, you have 3 different applications running in 3 different platforms. But is this approach good enough? Right? Because what are we doing? We are actually copy pasting the code from our mobile application to web application. That means we are writing it again twice. We are duplicating the code twice. So this is definitely not a good approach, right? We have to find a better approach for it. Now, what if we publish our mobile application as an NPM package? So as we saw, the requirement was just to build a login screen and a home screen. It was a very simple application. So why not publish it as an NPM package and use it as a dependency in your web application? So if you can see here, app mobile is being used as a dependency, and we are importing the app from the mobile and in our index.js file of web application, right? So now we are writing the code only once, and we are connecting the mobile application to both web and Electron, which is desktop. Okay, again, is this a good approach? Is this a reliable approach? Because the example that we just saw is a very simple application with just a login screen and a home screen, right? But for the production level applications, you might have a lot of third-party dependencies. You'll also have to make sure if the dependencies run in all of the 3 platforms that we're looking for, in all of the targeted platforms, right? So if you take up any application, you can divide that application into a view part and a logic part. So the view part will contain your UI components and everything, and also a third-party UI libraries like Native Base, and your business logic part would contain some of the application specific logics, services, stores, everything, and the third party dependencies again. So it's very important that to note the point that we also have third party dependencies in our production level applications. Since React is a library, you will obviously have a lot of third party dependencies. Now, the next thing to think about is how are we going to manage things when there are third party dependencies. And also it's a very important thing that each and every platform will have its own way of handling things, right? And each and every platform will have its own experience, user experience, touch and feel. So you also have to maintain all of those and share the code base simultaneously. So how are we going to do it? Simple. We are going to, the architecture matters a lot. So you're going to have your desktop application, mobile application and a web application, and you also have an extra shared application, right? So you first, whenever there is a project coming up, before starting the development process, you first have to identify if there are any shared UI components or if you have any services that you can reuse between the applications, right? So then dump all of those into your shared application, and all the platform specific features will be available in the respective applications, and then publish it as a NPM package and use it in mobile, in your applications, in platform specific applications, right? Now, there are certain design principles that you need to keep in mind whenever you are reusing the code base. The first one is DRY, which says don't repeat yourself. Again, the modular way of handling things, right? You always have to write, say you have a particular functionality, write one single method for that functionality and use it everywhere. Don't duplicate your code anywhere. Don't duplicate the logic anywhere, right? And the second principle that we want is KIS, which is keep it simple. If you are writing a method for a particular functionality, keep it simple. Don't give don't implement more than one functionality in a single method, right? You should write one single method, and that single method should handle the edge case of that particular functionality. That is completely to 100%, right? So these are the design principles that you need to keep in mind while you are reusing the code base. Now, we had a shared application wherein we had dumped all our shareable features. Now we have published it as a package, NPM package, and now we are using it as a dependency in our mobile, web and desktop. So now we could achieve it, right? Like the platform specific touch and feel experience and were also retained along with sharing the code base. We also saved the time, right? So we could finally achieve this. Now it's pretty sure that the last approach we saw is reliable even for the production level application. But when exactly should you structure your application based on this architecture? Should you like always structure your application based on the same architecture? No. You first have to think in product owner's perspective. Whenever there is a project coming up, right, you will have to think in product owner's perspective, think who are the target users of that application, and then start planning on structuring your architecture, right? Say if you have to build a application for a bank, so your the targeted users would be bank clerks, right? They would work on computers or laptops, and they need desktop applications, right? So you need to think in product owner's perspective and then start planning on structuring your architecture of the application. The architecture is a very important part of the development process. Now, these are actually not disadvantages, but these are like the extra things you need to do when you are trying to reuse the code base. Version maintenance is, say you have you have the same architecture, you have the shared folder, you have mobile, web and desktop, and whenever you are updating your React Native version, you have to make sure that the dependencies or the things that are present in shared application are compatible with it. Right. So if you are making any changes to the shared module, you'll have to make sure that it's running fine in all the 3 platforms. So version maintenance could be an overhead, could be an overload, right? Next thing is dependencies. I told you, third-party dependencies. You'll have to make sure that the dependencies that you use in your shared module should be platform independent, or you should make sure that the dependencies work fine in the targeted platforms. And the third thing is, if you already have a stable app, and at you know, in the by the end of the development process of that particular application, client comes up with the requirement of the same product in some other platform. So in that case, it's along with writing the code for the new platform, you also have to restructure your stable application, right, to share the code. So that is also an overload. Then the last thing is special requirement. By special requirement, I mean, say you have a mobile application or any application, and you are using a set of icons in that application. That application will be used by 10 different companies, and each company will have their own set of icons to be used, right? So when company 1 is being used, then you will have to replace all of the icons from each and every screen with the company's icons. Okay, so how are we going to handle this? How do we usually handle this sort of requirements in web? Anybody? Okay, we usually use Webpack configurations, right? We usually write that configuration object. If this is the company, then this should be the set of icons that must be used, right? And also Webpack, we have Webpack loader. So whenever a particular file is being loaded, we check if there is an icon being used, and we are going to replace that icon with the required ones. So that's how we do it in web. In mobile as well, we have a lot of approaches to do it. So in such, if you have such requirements in your applications, you will have to make sure that your shared module supports this sort of configurations. So you might also have UI components that are being reused, right? So in that cases, you will have to make sure that the configuration is being managed. The shared component, shared module supports this sort of configuration. Now, the reusing code base is obviously not a new concept, right? I mean, Facebook came up with React Native with the same motto. They wanted to write, initially before React Native came up, people used to write 2 different codes, for one for one for Android and one for iOS. Once the React Native came up, now people are have started using React Native just to write once and run it in both iOS and Android. We also have other options like Flutter, Vue Native, right? So yeah, this is about code-based reuse. The approaches that you use mainly depends on the requirement. It's always requirement specific. So based on your requirement, you'll have to decide on which approach you're going to. Think before you start your project, plan your architecture well based on the requirement, and then go with it. Thank you guys.